So Ken has a cell phone, which would be that right there. It detects two transmission antennas, one 7 kilometers away and another 13 kilometers away. So I imagine they would be these two towers here. So one is 7 kilometers away, the other is 13. So I guess by judging by the lengths, we could say that this is the 7 kilometer distance and this is 13 kilometers. And from its position, the two antennas appear to be separated by an angle of 80 degrees. So if you was to look from here to one transmission tower and then sweep out the angle towards the other transmission tower, this angle between them is 80 degrees. So we want to find out how far apart to the nearest kilometer. Sorry about this, that should be RE because we're Canadians. Are the two antennas. So we're looking for this distance here. So we can use one of the side, or one of the forms of the cosine law where you can solve for a side. So I would just write in here x squared equals, and then we don't really know the names of these sides, so I'm just going to substitute those values in. 7 squared plus 13 squared minus 2 times 7 times 13 times cosine of 80. And then we just do all the calculations. Now I don't have a very fancy calculator, so I just do things a bit at a time. So I got 49 plus 169 minus 14 times 13 is 182 cosine of 80 degrees. And 49 plus 169 is 218 minus 182 cosine 80 degrees. So these are two complete terms here. So we have to make sure that we calculate this first before we subtract from 218. So do the cosine of 80 and multiply by 182. So we get 249.6. Something seems to be wrong here. Well, let's, so we're going to end up having a negative value, and if we take the square root of a negative value, that's not going to work out. So did I do something incorrect here? Yes, I did do something wrong, and I'm not sure what it was. So I just did my calculations there. So this step here should be 31.6. Say 04. Okay, that's better. Now when I subtract them, I will get a positive value of 186.396, or basically 0.4. Take the square root of both sides, and I'll get 13.65. And it's to the nearest kilometer, so I'd say 14 kilometers, approximately. Okay, so it's always important to kind of make sure, just like when I made that mistake, it's very important to make sure that you kind of take the look at the reasonableness of your answer to make sure that it'll actually work out correctly. Okay, example 2. A triangle has sides that measure 5 centimeters, 6 centimeters, and 10 centimeters. Do any of the angles in this triangle equal 30 degrees? Well, we know that all of the sides are different lengths, and I'm not really sure how I'll draw this, but I'll just say, okay, that's that. Maybe like this, and maybe like this, ish. And I'll say that's 5 centimeters, 6 centimeters, and 10 centimeters. I didn't draw it to scale because I don't really, I'm going to be doing the calculations anyway, so I'm not going to be measuring this with a protractor. So we know that the total sum of all the interior angles of a triangle are 180. And 30 seems to be a fairly small value. So we know that the 30 degrees, one of the angles is 30 degrees. If one of the angles is 30, then the other two have to add up to 150. So those are going to be fairly large angles. So I would hazard to guess that the 30 degree angle would not be across from the 10 centimeter side, because the longer the side, the larger the angle across from it. And the smaller the side, the smaller the angle across from it. So what I'm going to do is I'm going to guess that if there is a 30, it'll be in this vertex right here. Just an educated guess. It could be here. I'm not it could be in this vertex. I'm not really sure, but I'm going to take a hazard that it's going to be across from the 5 centimeter length. So I need to find this. So let's say this is side A. I'm going to say this is vertex A. So I'm going to use this form of the cosine law and just rearrange the values here. So if I've got cosine A, then I'm going to have a squared minus b squared minus c squared all over a negative 2bc. Now I just have to substitute all the values in and see what works out. So A is 5, that's squared. B I'll say is 6. C I'm going to say is 10. And so we got 25 minus 36 minus 100. All over negative 120, which is negative 111 over negative 120. And when we divide those, we get 0.925. And therefore A is the inverse cosine of that. And we get approximately 22 degrees. Okay, so since I was looking at angle A being one of the smaller sides, A is the smallest side, so A would have to be the smallest angle. And since angle A is 22 degrees, that means there's a possibility now that the 30 degree angle, if there is one, is across from the side that's 6 centimeters long. So now that I've used cosine law, I'm going to use the sine law, because I know one complete ratio. I've got the side A, which is 5 centimeters, and I've got angle A, which is 22 degrees. That would be my complete ratio, and I want angle, we'll say angle B then, and I'll use the sine law. So sine of B over side B, which is 6, equals the sine of A, which is 22 degrees, over side A, which is 5. So sine of B is 6, sine 22 over 5. I will calculate that. We get 0.44953. And then I'll just take the inverse sine of both sides here. So angle B is 26.7 degrees, or roughly 26 degrees. So therefore, we can conclude that no angles are 30 degrees. Because, obviously, 22 degrees plus 30 is 52, and you subtract that from 180. Sorry, 22 degrees plus 26 is 48. Subtract that from 180, you're definitely not going to get it 30 degrees, especially for this angle across from the 10 centimeter side. Therefore, none of the angles are 30 degrees. So, there's the work listed at the bottom of the page. Thank you for your patience in watching this video. Please try a few of these questions this evening at home, and then come in to class tomorrow and work on the rest of those questions. So thank you for your attention, and we'll see you in class.